This is a battleship built by the United States 100 years ago. The engineers were trying to get the plane to take off from the deck. A special catapult was designed. It consists of a track and a 6-meter-high wooden tower. When the weight on the wooden tower falls, it'll drive the rope that connects the rails, pull the airplane to get it up to takeoff speed. However, it didn't take long for the catapults to be installed. The battleship's deck couldn't withstand the repeated impacts of heavy objects and was damaged. So the engineers tried to store the compressed air from the fish launcher in the cylinder. Propulsion for catapults. When the plane is ready to take off, compressed air is injected into the bottom cylinder. Make the ropes connecting the rails pull the airplane to take off. But the power of compressed air alone can't launch an airplane over 800 kilograms. For this reason, the engineer multiplies the tension of the rope by means of a pulley. That way the plane can take off smoothly on a 30-meter track, since the catapult takes up the entire foredeck. So that the plane can only land on the water, we'll have to winch it back to the ship every time. This seriously affects the maneuverability of the battleship. In order for the plane to land directly on the deck, British engineers build a bigger ship. Although the front of the deck is reserved for adequate space, but pilots still need to have great piloting skills to avoid the control room in the center of the ship. One mistake, and you're off the deck and into the ocean. So the engineers moved the central control room to the right side of the ship. Redesigned decks, but weight deflections caused the ship to tilt. To do this, the engineers had to find a way to balance the battleships. They started by filling up the left chord's gas tank, utilizing the weight of the fuel to offset the weight of the control room. However, with fuel consumption, the battleship is tilting again, so they moved the hangar to the left chord. But with the addition of crews and equipment, the ship is tilting to the right again. After 20 years of trial and error, eventually the engineer extended the left string outward and transferred heavy equipment to balance the battleships. And so the mother of all modern aircraft carriers was successfully launched in 1937. It can hold about 50 fighters. Engineers, to boost the number of airplanes, filled the hangar and parked the extra fighters on the deck. This makes it impossible for pilots to control their speed when they land, hit a parked airplane, cause an accident. For this reason, the engineers installed a blocking lock on the deck. It consists of hydraulic cylinders and a pulley mechanism to dampen the momentum generated by the airplane when it lands. Now the carriers can land fighters safely on their crowded decks though, but this also makes the deck a major target for enemy fighters. Once the deck is damaged, aircraft will not be able to take off and land. For this reason, the engineers laid the decks with armor. Now, although the bombs won't penetrate the deck, but the extensive use of armor has made the carriers top-heavy, reduced stability. Trying to stabilize it, we'll have to make the carrier wider. But the wider hull makes it encounter more resistance. So the engineers increase the length of the carrier, keeps the hull streamlined. That's how the carriers almost doubled in weight and size. However, the larger size makes the carrier vulnerable to attack. For this purpose, the engineers designed a special long-range radar detector. It scans the sky by, make all intruders within range show up on the radar, allow the escorting fighters to intercept it first and accurately. Even if the intruders avoided the escorting fighters, they couldn't get close to the carrier, because the defense guns on the deck can accurately destroy anything within 8 kilometers. As carriers continue to improve, fighter planes were also upgraded from early propellers to jets. Faster, bigger jets make safe landings a challenge again. Because of its speed, pilots have a hard time finding the right angle for landing. It's easy for a fighter to hit the deck or the stern, cause a serious accident. So the engineers analyzed the best angle for landing. Then a laser beacon was installed on the deck and fixed the light at the optimum landing angle by means of a reflector. This way the pilot only has to stay within light range to land safely. However, the approach ignores the effects of waves, causes laser signals to wobble around. To do this, the engineers fix the mirrors to the gyroscope mounts. That way, no matter how rough the waves get, the laser signal remains at a safe landing angle. Now the carriers are getting big and fast, but the fuel only allows it to sail for 3 days. The engineers installed 8 nuclear reactors in the center of the carrier. It uses the splitting of uranium atoms to release energy, heating water to over 250 degrees to produce steam. The steam is then piped into the turbine unit, spin, driving a huge gearbox, then drive the propeller, provide a constant stream of power to the aircraft carrier. Because there are too many nuclear reactors, engineers had to encase the reactor in hundreds of tons of lead to protect the crew from radiation damage. But this also exposes the ship to the effects of gravity, causes the keel to bend. So the engineers had to redesign the interior of the carrier, reinforcement keel with steel lattice honeycomb structure. And so the world's largest aircraft carrier was born in 1961. It has 8 nuclear reactors inside that are capable of meeting the power needs of 500,000 people and enabled it to sail on the sea for 20 years.